Hello everyone and welcome to a new thing that I'm doing, which is watching videos. Oh, no, very new, I know. This time I will have a look at the video, is theoretical physics actually pseudoscience? And apparently Michio Kaku has the answer. And apparently it's a crisis in cosmology. Well, that is interesting. This time it's from Sharon. I don't think we have had Sharon before. So, hello, Sharon. In case you should see this, because surprisingly, a bunch of the flat earthers that I react to actually look at the reactions, which is pretty nice. So, hi, Jaren. In case you're seeing this, first of all, thank you very much for watching. You're one of the, 3 viewers I have on this channel. As you probably don't know my channel, unsurprisingly, I do things blind, right? So I don't prepare, because I don't really have the time, and I'm just doing this for fun, right? I'm an astronomer, or I'm currently writing my master's thesis. I'm also in the master's level thing of my physics degree. Yeah, and since you clearly have something to say about astronomy, I would like to comment on it.
Houston, we have a problem.
I have not seen the video yet. I've seen the first 1.5 minutes. Also, I have accelerated it to 1.25, I believe, as is customary. Also, I have changed the location of my microphone because I noticed that it was a bit silent in the last part, so yeah.
What you're seeing here is the rock.
What's going on, everyone? It's Jaren from Jarenism, back
Hello, Jaren. It's Olaf from Olaf Das Astro.
with another video for you today. Should be a short one, as I am asking the question, is theoretical physics actually pseudoscience?
It is not. It adheres to most scientific standards, pretty much all of them. Of course, some are not applicable to theoretical physics, but still.
Seems easy enough, but I don't want to simply tell you the answer. I'm sure you know my opinion, but rather
I believe you do.
I will provide you with the evidence and then allow you to formulate your own opinion or your own answer to the question. So let's get started. First, what is theoretical physics? Well, theoretical physics uses math and theory in order to come up with or derive the fundamental laws of nature and to make conclusions from these laws.
That is in principle correct.
Yep. Ideas in mathematics giving little to no weight to experiments or observations.
And this is very wrong. Okay, how is theoretical physics usually carried out? Now, note that I am at no means a theorist. More traditionally, I will talk a bit about that later, modern physics can be subdivided into 3, a modern physicist can be subdivided into 1 of 3 categories. The first one is experimentalist, who does experiments. The second one is a computer person who does things like simulation or data science, sometimes both. And sorry, my phone is doing stuff in the background for the first time today, which is very annoying. And the third row is being a theory person, right? And I am not a theory person, at a long shot. I am somewhere in between experimentalist guy and doing computer stuff, right? So yeah, just as a preface, right? So what is theoretical physics then? Well, you use some laws of nature that you have already been able to describe, and you try to go a little bit further. A great example, if you will, of the accomplishments of theoretical physics would be Maxwell's equations that can be derived solely from theory and that give us values that we can measure also only from these equations. You don't need to do any experiments, and yet you arrive with what we later then can measure. For example, the speed of light. The speed of light one can get out of the Maxwell equations by only solving them for something that travels through no medium. Then you get the speed of light as a solution, which is that, and you get that out of theory. Maxwell didn't do any measurements to get the speed of light. He just said, from the theory and the data that we have had previously, and from the equations that can be formulated out of theory, the speed of light should be that in the vacuum. And well, turns out it is that. So theory often is correct. It is wrong sometimes because stuff is missing and stuff was not taken into account at the time the theory was discovered, if you will. Same holds for Maxwell's things, but like in general, a theory is kind of you put all of the mathematical formalisms that you have from the more experimentalist side, and you try to find some mathematical skeleton kind of for it, in which to put it all in and see if you can get a prediction out of there. And more often than not, it turns out that you can, and that those predictions are pretty stable for the most part.
Sounds fun, huh? Books have been written and questions have been asked because to some it has become obvious that physics has been stuck for years, because the belief in beauty and math have become so dogmatic that it now conflicts with scientific objectivity.
You're very much overdoing that here. There are some issues, I would argue, with some branches of physics, especially the more theoretical side of particle physics and like what's specifically called mathematical physics, which technically isn't theoretical physics, but no one knows that unless you're a physicist. So there are some issues with people building mathematical constructs and then trying to get their data to kind of explain the mathematical constructs. There's a really nice video by Sabine Hossenfelder, who is a physicist and who talks about this issue with specifically particle physics. But it's still science. Don't get me wrong, it's just not exactly good science. It's still science though. Yeah. So yeah, but other than that, mathematics is I would argue one of the most important part of physics. That's why they bother us for like terms on terms with mathematical courses, because you need to understand that a lot of the things in nature can only be described with pretty complex mathematics, or like complex to us mathematics.
That a focus on mathematical elegance rather than reality.
They're not necessarily focused on elegance. Also, what is mathematical elegance? That's not an absolute term. If you say it's focused on mathematical elegance, you would need to specify what it is first. There is no absolute elegance in anything.
Has led the so-called science astray.
That's your opinion.
Reminds me of a quote from Nikola Tesla, who of course was a real scientist, not a theoretical physicist, who said, "The scientists from Franklin to Morse were clear thinkers and did not produce erroneous theories. The scientists of today think deeply instead of clearly. One must be sane to think clearly, but one can think deeply and be quite insane. Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation, and eventually build a structure which has no relation to reality."
Some do that. Not as drastically as is described here, and I would like to argue that Tesla, especially towards the end of his life, got a bit insane. His wife was a pigeon. But I'd argue that sounds like an argument the enemies of Einstein made, right? When Einstein came up with his field theories, the general theory of relativity, one of the points of critique was he has only gone with mathematics, and which is in theory a good statement, right? But he seeked out to test all of the predictions, right? So you're criticizing how they arrive at the conclusion and not the conclusion, which is what you need to do. The predictions that Einstein's field theory made, or like the general theory of relativity, were bang on. It's not. I'd argue it's not all too important if he came there from only observation, which I would actually argue is extremely difficult. I don't think that's something that you can do. You can, I'd argue, only arrive at Einstein's field equations, or like the general theory of relativity in general, through theory, and a lot of that, and a lot of quite difficult mathematics.
Nikola Tesla. Things like dark matter, string theory, the Big Bang, quantum gravity, relativity, and
so many things. Let's go through them one by one.
Tesla. Things like dark matter.
Dark matter is a current idea. Dark matter is an hypothesis. It's the current frontier of science is dark matter. There is a decent chance that dark matter just isn't a thing. And that's fine. That's one of the hypotheses. We are not portraying dark matter as a cut deal. It is our best guess at the moment, like the data points in some general direction of something that should be similar to dark matter. But if it's not, we'll find another thing.
String theory.
String theory is an explanation attempt. It's more of a mathematical model which with to calculate other stuff. It's like the model the model of the atom by Bohr, right? Niels Bohr constructed a model of the atom that he knew was wrong. He did it in order to make calculations, and that's something you can do very, very nicely with that. The Bohr model is an atomic model that is known to be wrong. Niels Bohr knew that it was wrong, yet he still described it because it simplifies a lot of mathematical things. And the predictions it makes within a very well-defined and very well-known limit are very accurate.
The Big Bang, quantum.
The Big Bang is just an observational fact. We can trace the expansion of the universe back to basically t equals 0. It's not exactly 0, but it's close enough. Yeah, that's just an observational fact. You don't need much theory for it. You can just say that the universe has always expanded as far as we know, and that we think that it was extremely dense in the very beginning. That, and all of that follows from observation. None of that you need theory for.
Quantum gravity, relative.
Quantum gravity is a whole different kind of worms, and also, again, one of the frontiers of science. We haven't quite figured it out yet. We know that there has to be, or we think that there has to be some sort of quantization going on, also in gravity. We just haven't found it yet. That's, again, a hypothesis.
Relativity, and so much more.
Relativity is, I'd argue, apart from the standard model, the best theory that physics has, both special and general. Yeah, I don't really know what else to say here. Relativity is corroborated by so much data and so many observations. Yes, it came out of theory, but Einstein himself was very worried in the beginning because there was no data available to back him up, because all of the observations that were needed to confirm the stuff that he came up with, like none of the observations were made yet. And then he asked multiple people. He was actively looking for astronomers to confirm the model that he calculated out of nothing, essentially. And eventually they did. Eddington. There was a guy earlier, I keep forgetting the name, I believe it was Stern. Fröhlich. An astronomer called Fröhlich. He was supposed to do it, but then the First World War happened, and it was supposed to be in Siberia, and traveling from Germany to Russia in the First World War was probably not an exactly good idea. So yeah,
have all come from the minds of theoretical physicists. Let's
I'm unsure about that. Mostly because all of those were group efforts. But sure,
list some of these theoretical physicists because maybe you've heard of some of them. Nicholas Copernicus, who formulated the Copernican principle that the Earth or human beings could not possibly be in a privileged position in the universe.
I'd argue that Copernicus was more of an observational person, so pretty more on the experimental side. He was also a natural philosopher. So that's actually the only thing I prepared for today, because I got until here. And then I thought I would make a video about it, or like multiple, judging from the time. So hi! That's the plot of where physicists or people you talk about in your video can be. There is experimentalists, people who design and run experiments and derive data from there. Historically, there was experimentalists, and then there was theorists, right? Now, since like the couple of last decades, simulation or like data scientist, I guess you should really add it with data scientist. So you're either a simulation or a data scientist. That kind of added all to the stuff. They used to be only experimentalist and theorist. Now we have the simulation / data scientist. Also, some you can be is a natural philosopher. Not exactly like it's not physics, but it's kind of adjacent to it, I would argue. Yeah. So just Olaf, hi, this is me again. I'm somewhere around here, and I'm very comfortable here. I don't want to go there because it's very ugly and complicated over there. So I would argue that Copernicus is in two places, kind of. A lot of his stuff is like in the natural philosophy thing, but a lot of his stuff are derived from observations. So I'd put him. I don't know what's going on. I would actually put him at kind of both of these places at once, right? Just to make sure we can have a brief overview of Copernicus. Sorry, sometimes I can't spell. It's especially bad in the videos. First of all, at the time when he lived, Copernicus, science wasn't a thing yet. Science, if you are really generous, started with Galileo. Some would argue it started with like 1850s, like slightly pre-Maxwell with these people, right? When it comes to the Copernican system, he got his ideas mostly from observational data, right? Amongst other things from the backwards motion of the planets, which is very much an observational approach to things. In modern science, we would call someone who looks at things and derives laws from the things he looked at, that would be an experimentalist, or at least someone who does data stuff, right? So that's where I would put Copernicus. Actually, let me. Yeah, that's where I would put Copernicus here.
Or Giordano Bruno, who told us that the stars are just like other suns.
That's natural philosophy, not necessarily science.
Or Galileo Galilei, who pushed the ideas of heliocentrism.
Now, I don't know why you put Galileo in the theorist pile. That makes no sense whatsoever. Galileo was fundamentally an experimentalist. He came up with the first telescopes, right? So I'm putting it firmly in the experimentalist thing. He made conclusions from the first telescopes. Yes, he made some observations about natural movements like constant downward acceleration, but those were backed up by experiments, by like essentially he experimented around with dropping objects from slopes, for example, and figuring out the natural rate of acceleration from that. Very solidly in the experimentalist category. I don't know why you think that he's a theorist. I don't think you quite understand what theory is.
Or Johannes Kepler, who came up
more or less the same holds for
with
Kepler.
mathematical laws of planetary motion.
He derived all of these laws from observational data supplied to him by his former master, if you will, Tycho Brahe. So Kepler, again, firmly in the hand of experiments. And I think my cat wants something. Yes, my cat definitely wants something. I will be right back.